Okay, whoever watched Complex Numbers Part 1 video, you know that I promised I will come back and help you figure out how to raise I to power much higher degree. Like I to power 37, I to power 44, I to power 19, and so on. It's absolutely crazy to go from I to 0, I to 1, I to 2, right? So there is a method, there is a way to raise to much higher power without going through every single degree. All right. So first of all, first one, I want to remind you that I is equal square root of negative 1. Now let's go I to power 0 is equal 1. I to power 1 is equal I. I squared, it's going to be square root negative 1 times square root negative 1, right here, which is going to be negative 1. I cubed is equal I squared times 1. Times I to power 1, which is going to be negative 1 times I, right? And the result is going to be negative I. And I to 4 is equal two ways, I squared times I squared, or I cubed times I to power 1. So I squared is negative 1 times negative 1, and that's going to be positive 1. And I cube is negative I times I. So negative I times the I, it's going to be negative I squared, right? So negative I squared is negative 1. So result is going to be positive 1. So it doesn't matter which way. So I to power 4 is equal 1. Okay, this is enough to figure out the imaginary number raised to much higher degree. Let's start. I to power 36 is equal. So can I represent, I'm going to use this 36, I can either take I to power 3 to power 12, right? Or I can represent I to power 4 to power 9, right? Okay, either way. So let's see, I to power 3 is negative 1 to power 12. Or I to power 4 is positive 1 to power 9. So since negative 1 to power 12, because we have even degree, we are going to get positive, right? 1. To refresh your memory real quick, if I'm raising negative number to odd degree, let's say 13, you get the negative number. But if you raise negative number to even degree, any even degree, you get positive number. Okay? So we get 1, and also here we get 1. So the answer is going to be 1. I to power 36 equal 1. So either way, I'm not going to go every time several ways. So you pick whichever you like. It just because it's the first time I showed. Next one, I to power 48. I like to work with degree 4 if I can, if degree is divisible by 4, because 4 is equal 1. Degree I to power 4 is equal 1. So I to power 48. So that is equal I to power 4 to power 12, which means 1 to power 12 is equal 1. Next, I to power 29. That is equal 29, I can take 28, right? 28 divided by 4 is 7. I to power 4 to power 7, that's 28. And there will be left 1, right? Times I to power 1. So this will be equal 1 to power 7 and then times I. Result is going to be I. Next one, I to power 27. I can break down I to power 27. If I go with degree 4, I can write down I to power 4 to power 6 and plus I to power 3, right? Okay, so I to power 4 is 1, 1 to power 6, and I to power 3 is negative I. Correct? So the result is going to be, hold on, let me put multiplication here. Yeah. Result is going to be I. Or I also could take I to power 7 is equal I to power 3, right? To power 9. 3 times 9 is 27. So I to power 3 is what? Negative I, right? So negative I to power 9, it's going to be negative I. Oops, here also negative I. Okay. I to power negative 14. I'm going to take it as a 1 over I to power positive 14. Why? Because a to power negative n is equal 1 over a to power positive n, right? Okay, and from here, let's see how we're gonna break it down. I wanna break down as a 12 and 2. So, which means I to power 4 to power 3, and then times I to power 2. This is equal 1 over I to power 4 is 1, 1 cube is 1, and I to power 2 is negative 1. So result is going to be negative 1. Next, negative 2I to power 10. What do? I separate negative 2 to power 10 and then put times I to power 10. So since negative 2I raised to power 10, which is even number, result is going to be positive. And that is going to be 1024. And times I to power 10, how I can break down? Several ways. I can break down as a 4 squared, meaning 8 and 2, right? And 8 represent as a 4 squared. Or this time I would like to represent as a I squared. Will be I squared to power 10. I mean, to power 5. I'm sorry. Yes? So we have 1024. I squared is negative 1, right? Look here. Negative 1, right here. To power 10. Remember, when we raise negative number to even power, we are getting positive. So answer is going to be 1024 times 1 equal 1024. Okay, next one, I to power 3 minus I to power 24. So I to power 3, I'm going to write down it's equal negative I. We already know from this formula, right? And minus 24, it's the best way, I to power 4 raised to power 6. Why it's the best way? Because we know that I to power 4 is 1. So we are getting negative I, and I to 4 it's minus 1 to power 6. It's going to be negative I minus 1. Okay? So we can write down in the format of complex number a plus bi. So which means I can rewrite negative 1 minus I. So to get in the format of complex number. Okay. And one more. I to power 3 let's take different one. I to power 13 minus I to power 4. Okay, so I to power 13, I'm going to break down 12 and 1 degrees, which is going to be for degree 12, I'm writing 4 to power 3, and minus I to power 4, we know, 4 to power 3, and then times I, yes? And minus 1, because I to power 4 is 1. So result is going to be 1 to power 3 times I minus 1. So we get I minus 1. Or if we want to write down in the form of a complex number, it's going to be negative 1 plus I. And lastly, I'll solve another one, I squared I squared plus I to power 4. I squared, we know it's negative 1. And I to 4 is positive 1. And result is 0. All right. Thank you for watching. I hope it did help. This is from previous video. Okay, I hope that helped you. And I'll see you in next video. Thanks for watching.